Hey y'all. In this video, we're going to be taking a look at centers of triangles. Our question that we should be able to answer by the end of today is how can we construct the circumcenter, incenter, and centroid of a triangle? So today we're going to be taking a look at a whole lot of different properties of triangles, and then we'll go through and solve some problems with them. So let's just start with some vocabulary. So the first part of this video, I'm going to be talking and doing some vocabulary, and I have a drawing that I've already done, so I'll show you how I got to that drawing, etc. and so on. So to bisect something means to cut it into two equal parts, and in simpler terms, it means to cut it in half. Perpendicular bisector means to cut a line into two equal lengths, and it's also going to be perpendicular. So perpendicular, we know, intersects at 90-degree angles. Bisector is going to cut it in half. So a perpendicular bisector is a line that it cuts two things in half and is perpendicular to some other line. An angle bisector cuts the angle into two equal parts. So if the angle was 100 degrees, an angle bisector will give us 50 and 50. If the angle was 70 degrees, the angle bisector would give me 35 degrees and 35 degrees. A median is a line connecting the vertex of a triangle to the midpoint of the opposite side. So the line that connects the vertex of a triangle to the midpoint of the opposite side. So I'm going to go through and explain how we got this. So ideally, in the perfect world, you'd have this paper in front of you. You'd have a ruler and a protractor. But if you're at home, you might not have those kind of things. So I'm going to show you what it looks like in blank form. And then when I go through and do all four of these steps, we're gonna be finding the circumcenter of the triangle. So here's my completed one that I've already done. Let me zoom in. Okay. Step 1. It says find the midpoint of each side of the triangle and using a protractor create the perpendicular bisector. So I've gone through and I found the midpoint for each side. So A, B, my midpoint is this point right there. C, B, my midpoint is A. And C, A, my midpoint is this point right there. Then I use a protractor and I have 90-degree angles right there. So I did that in the black. So those are my 90 degrees. Part B says label the point where all three perpendicular bisectors intersect as point P. This is the circumcenter of the triangle. So right here, this red dot P is my circumcenter. That's where all three perpendicular bisectors intersect. So where this 90-degree line is, this 90-degree, and that 90-degree line. Where all three of them intersect is this point right here, and that is my circumcenter. With a different color, create a straight dotted line from points A, B, and C to point P. So I did that in the highlighter pink color. So this highlighter pink color there connected to my circumcenter. I took my vertex, connected it to my circumcenter, and I took C, connected it to my circumcenter. What do we notice about the lengths of the dotted lines? We should notice that AP is congruent to BP, and that is congruent to CP. So all of these from my vertex to the circumcenter, all of these should be the same. So that's what I got from this first section right here. So this first section is telling us about medians, and it's also telling us about perpendicular bisectors. And I apologize, there's no medians in this one. This one is telling us about perpendicular bisectors, and it tells us how to find the circumcenter. And so our theorem that we have here, the perpendicular bisectors, let me slide up a little bit. So this is something that you should write down and put in your notes. The perpendicular bisectors of the sides of a triangle are concurrent, meaning they intersect at a point equal distant from the vertices. Again, the perpendicular bisectors of the sides of a triangle intersect at a point equal distant from the vertices. So I know I quickly went over this up here, but if you wanted to kind of investigate on your own, you should notice that they all intersect at the same point, and the following is true. So from your vertex to your circumcenter, all of those distances are the same. They are congruent to each other. All right, next thing that we're going to take a look at. So again, I have another blank triangle. I'm going to go through these 4 steps over here, and we're going to discover something over here about our incenter and our angle bisectors. So I've already have my pre-drawn picture here. I'm just going to go through and show you how we got what we got. So we're going to be finding the end center of our triangle. So step 1. Okay. Use your protractor, find the measure of each angle, cut this angle in half to create an angle bisector. So again, I've already done that. I cut angle A into 2 congruent parts. That's what my little curvy tick marks mean. I cut C in half and I cut B in half. So I've already gone that. I cut each of my angles in half. Part B, connect the angle bisectors with a line. Label their intersection as point R. This is the end center of the triangle. So it is an R here. Let me try to make that a little. So this is R in the red pen color there. So this is R. This point R is where all of my angle bisector lines intersect. So the dashed line is my angle bisector, C dashed line, that's my angle bisector, and from my vertex B over here to the center, that is my angle bisector. Where all of those angle bisectors intersect, that is your end center. And I have that written over here in the red if you want to jot that down. So R is my end center. It's the point where the angle bisector lines all intersect. Part C, with a different color, create a dotted line from point R to each side of the triangle so that the line is perpendicular to the sides. So I've already used my protractor previously and done that. So I started at my end center. I created a 90-degree line here. So you see a little 90-degree mark. This is a 90-degree mark here, and this is a 90-degree mark here. What you should notice, so part D, what do you notice about these dotted lines? They all are congruent. XR is congruent to YR is congruent to ZR. So XR, RY, and RZ are all congruent to each other. So down here at the bottom, what you need to know about an end center is that the bisectors of the angles of a triangle are concurrent, meaning they intersect each other at a point equal distant from the sides of the triangle. So Rx is equal to Ry is equal to Rz. So I have my end center here that's formed from the angle bisectors. All of those intersect at the same spot, and that is my end center. The circle that's formed, if I were to connect all of those points, that's called the end circle. All right. And one more thing that we'll take a look at, and then we'll get into some problems. So again, I got another blank triangle. I've already filled in everything, but I just want to show you where I'm getting stuff from. I'm going to be going through and following these 2 points here, and I'm going to be constructing the centroid of this triangle. All right, so here we are. Part A, it says find the midpoint of each side of the triangle using a straight edge. Connect the opposite angle to the midpoint. This is called the median of the triangle. So the first thing that I did, I found the midpoint of every single side. So A, B, my midpoint is G. C, B, my midpoint was J. And C, A, my midpoint was H. So I labeled those. Now what I did is I connected the midpoint to the opposite angle. So I took my midpoint here and I connected it over to vertex C. I took my midpoint here, connected it over to vertex A. And I took my midpoint here and connected it over to vertex B. So all of these lines are called a median. This is a median, that's a median, and this is a median. Part B, label the point where all 3 medians intersect as point M. So I did that in the red color. So point M. This is called the centroid of the triangle. So my centroid, I wrote that out here. Your centroid is where all the medians intersect. So your centroid is where all the medians intersect. And a median, you take the midpoint of one side and connect it to the vertex of the other side. So what we should get from this is this median theorem right here. The medians of a triangle are concurrent. That just means they intersect. The medians of a triangle intersect at a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. So what that means is if I take this median right here, say I'm going to look at CG. Say I'm looking at CG. So if I'm looking at CG, it's 2/3 the distance across. So you're going to have to look at it. So this part is a little longer. So that's the 2 part. This part over here is the one part, and together it makes a whole, WHOLE. So this side is 2/3 the distance of the whole side. So the longer side is 2/3 the distance of the whole side. So AM is 2/3 of AJ, BM is 2/3 of BH, and CM is 2/3 of CG. So what we're going to do now, I know that may have been a lot, especially with the pictures and things like that. So if I flip over for just a minute, we learned about the circumcenter. The circumcenter is where all three angle bisectors intersect each other, and my highlighted pink sections are all congruent to each other. Then we learned about an in-center. That's the point where all the angle bisectors intersect one another. And then in this part right here, we learned about where all the medians intersect each other, and they gave us some different properties. So what we're going to do now is go through and do some problems, some applications pertaining to circumcenter, in-center, and a centroid. So I'm going to try to get the picture in here along with the problem. All right, so I think that's the best that we can do there. So it says example 4. Applications of circumcenters, in-centers, and centroids. In triangle LMN, P, Q, and R are the midpoints of LM, MN, and LN respectively. We want to go through and find X, find Y, and find Z. First, I know that this is a median problem. So I know that this is a median problem because I don't have anything dealing with the angles. So the angles, I would need to know if I had like perpendicular bisectors, because that would be 90 degrees. I would need to know if I had angle bisectors, but I don't know any information about any of the angles in this picture. I only know about the size. So I know that this problem is asking me about medians. So since I know that this problem is asking me about medians, I can use this that's up here at the top of your screen. I can use that to help me. So my ratio is that one section of my median is 2/3 of the whole section. So for number 1, it says find X. It says that MB is X, so I can look at my picture here. MB is X. So let's write that out. You don't have to, but just so that we have all of my information. And I know that RB is 2. So from R to B over here where my pen is at, that distance is 2. So I'm using my median. My whole median is MR. So from M to B, that is X. From B to R, that is 2. Now I'm going to use the fact that my ratio is 2/3. So this longer side here is 2/3 of the whole entire side. So if this little section is 2, so if from here to here that section is 2, the other side is 2/3 more than that. So if I explain that a little bit better there, I know that my answer is going to be 4. Okay. And how do I know my answer is going to be 4? Because I know that one side is 2, and that one side counts as 1/3. And my other 2/3 have to be 2 plus 2. So I know that one side, this counts as 1/3, and this counts as 2/3, so that my whole distance is 6. But they're not asking about the whole distance, but we could write that out for studying purposes. Whole median is 6. But I don't need to know about the whole median. I only need to know that one section, X is equal to 4. So your ratio is 2/3. 2 counts for 1/3 of the whole length. So my whole distance, I could just do some multiplication or addition to figure that out. So my whole median, MR, is 6. Moving on. Number 2. Number 2, I'm finding Y. So let's look at my other median. This time, I know that I'm looking at median QL. So maybe I should do this in a different color. I'm going to do this one in red. So this time, I'm looking at this median. Okay. I know that QB is Y plus 1. So QB is Y plus 1. I know that LB is 3.6. So I got that right from my picture. LB is 3.6. So since I know that my longer side, I know that my longer side is going to be the 3.6 side. So I know that I need to cut my other one in half so that I don't have 2/3, I only have 1/3. So the equation that I have is y plus 1 equals 1.8. So I cut this in half because that's the bigger side. That's the 2/3 side. So I need to cut that in half so that I only have 1/3. So I divided it by 2. I solved this equation, subtract 1 from both sides, and I got the following. And number 3, I will highlight this in my pink highlighter. Hopefully it'll show up. Well, hopefully it doesn't take up too much space on my picture here. So this time I'm trying to find Z. So this time I'm looking at this median. I'm looking at this one right here. So that's what I just highlighted in that pink color there. So this time I know that PB is 2Z. PB is 2Z. And I know that NB is 2.8. So I'm going to do the same thing I did for number 2. I know that 2.8 is 2/3 of my median. It's the longer side. So I'm going to divide it by 2 so that I can get the 1/3 section. So now I have 2Z equals 1.4. I'm going to divide both sides by 2, and we get Z is 0.7. All right, so that's number 1, a little bit of practice doing medians. 2 more problems we'll take a look at. Number 2, and let's get our picture in there at the same time. All right, lines A, B, and C are perpendicular bisectors of triangle PQR, and they meet at A. We want to find X, Y, and Z. So let me zoom in here. The problem tells us that these are perpendicular bisectors. Since I have perpendicular bisectors, there are some things that I know. I know that this section here is congruent to this section here, so I'm going to put tick marks. I know that this section here is going to be congruent to this section here. So boom, 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 boom. And I know down here at the bottom that this section here is going to be congruent to this section here. So 1, 2, 3. 1, 2, 3. Right. And I know that I have some perpendicular bisectors that are in here. And I also have some angle bisectors that are in here. Okay. And let me highlight this section here. Make this a little thicker. Make this a little thicker. And I'm going to make this a little thicker. So now this is what my picture looks like. So now I have found my circumcenter. Now that I have found my circumcenter, because of my perpendicular bisectors, I know that some sections in here are going to be congruent to each other, so I can set them equal to each other. So this thickened line here, this thickened line here, and this thickened line here are all going to be congruent to each other because they are my circumcenter, and your line segments from your circumcenter are congruent to each other. So now that I know that, I'm going to zoom out a little bit so we can start to find some of the things that the question asked me for, okay? So I'm going to try to leave it there so we can see our picture. All right, so number 4 asked us to find X. So X is right here. So that's the 8X plus 16. And I'm going to set that equal to 24. Why 24? Because I know that this point here is my circumcenter. Where all 3 of these thickened lines intersected, that is my circumcenter. So this section here is congruent to this section here, is congruent to this section over here. So I just set them equal to each other. We go through, solve the equation. X equals 1. Number 5, we're looking for Y. I'm going to do the same thing. I'm going to do 5Y minus 6. So that's this segment here. This segment here is 5Y minus 6, and I'm going to set that equal to 24. Because again, I know that this segment is congruent to this segment, is congruent to this segment. So I solve my equation. Y equals 6. And last one, number 6 asks us to find Z. So Z is right here. So I know that this segment is congruent to this segment because I had perpendicular bisectors, and the bisector cut my triangle side in half. So I know that 7z plus 4 is equal to 18. Because the tick marks that we put earlier, I know that this is congruent to this. Go through, solve the equation, divide, and we got 2. All right, and I got one more that I want to look at. So I know it was a lot in this one video. Feel free to pause it, rewatch something. Okay, so last one, number 3. Okay, algebra. In triangle ABC, BF is the angle bisector of angle ABC. AE, BF, and CD are medians. So that's going to be important for us to know later on. They are all medians of one another. And we know that medians, you take the midpoint of one side, connect to the vertex opposite of that. And P is the centroid. And your centroid is the point where all your medians intersect. So we're going to be using the 2/3 rule that we did for number 1. So let me scroll down just a little bit. Since I'm dealing with medians and centroids, I'm going to be using this theorem right here. So this is the one that deals with the 2/3 ratio. So if you have a median, one side is going to be 2/3 the length, and the other side is going to be 1/3 of the length. All right, so here we go. Number 1, find x if dp is equal to 4x minus 3 and cp is equal to 30. So let's point those out in our picture. So dp, this little space right here. Okay, so I'll try to leave my pen there for a minute. dp is 4x minus 3 and cp is 30. So this section is 4x minus 3. This section is 30. This section is 2/3 of the whole median. So CP is 2/3 of the whole median. So this part counts as 1/3. So if this section is 30, I just need to divide it by 2 so that I can get 1/3 instead of 2/3. So the equation that we're setting up is 4x minus 3 equals 15. Add 3 to both sides and divide. I got a fraction, but that's okay. I got 9/2. So for number 1, I got 9/2. Okay. Number 2, I'm probably going to write, actually I don't need any work for number 2. Number 2, find y if AP is equal to y and EP is equal to 36. So looking over here, I see that AP is this space here. And I see that EP is 18. So EP this time is the 1/3 section. So this little segment right here is 1/3 of the whole length. So if I double this, I will get the 2/3 section. So again, I'm going to say that again since I didn't write it out. This shorter side is 1/3 of the whole median. So this is 1/3, this is 2/3. If 1/3 is 18, all you have to do is double it to get 2/3. So the answer for number 2 is 36. So we doubled it. So the answer for number 2 is 36. Number 3, I will jot down here. Find z if FP equals 5z plus 10 and BP equals 42. So if I go through that again, let's see where it is in my picture. FP is right here. So FP is 5z plus 10. BP is 42. BP is the 2/3 section because it's longer. So this is the 1/3 section. 2/3, 1/3. So if this section is 42, if I divide it by 2, it'll give me the 1/3 portion. So the equation that I'm setting up is 5x plus 10 equals 21. I'll go through and we're going to solve this equation. Subtract 10 from both sides and divide. I got a fraction, but that's okay. Nothing wrong with a fraction. And this last one is going to require us to do a proof, but we're not going to be doing proof, so don't worry too much about that. So a quick recap, because I know that there was a lot in this one little section here. So we learned about the circumcenter. Circumcenter is where all three angle bisectors intersect each other, and those line segments are congruent to each other. We learned about the end center. The end center is where your angle bisectors connect in the middle. And I also have some perpendicular lines that I draw in here, and those segments are congruent to each other. And then the median one is the 2/3 rule, I like to call it. The centroid is where all the medians intersect each other.